Hello all, welcome to Tech with SAS. Till now, I have covered various design patterns, design principles, and today we are going to cover yet another topic, which is quorum, right? And as we know that systems are mostly distributed nowadays, it means that there are multiple servers, right, in a system, which are also called as clusters. So when we have multiple servers in a cluster, we have to replicate data across all these servers, right? And the main benefit which we get by these systems which are distributed that there is a high fault tolerance and high availability, right? Because you have multiple servers in a cluster which are serving to the client, right? So even if a couple of servers goes down because of any reason, you can still serve your clients, right? But now the challenge is that because in that cluster you have multiple servers and maybe a few servers are up, few might be temporarily down, right? So how do you decide that whatever transaction is happening, it's success or not, right? And how we basically replicate data across all the servers, that whole principle, right? So for that, for example, if we have, suppose we have these five servers, right? And because you might be using load balancers in front, so one of the servers will get the write request, right, or read request. So how do we make sure that all the replicas or nodes are consistent, right? This is a very big question when we talk about the systems which are distributed. And the problem is this solution. This I mean, the solution to the problem is right. Is basically the quorum, right? So quorum is the concept. In the plain English word, we can say majority, right? So whatever majority says, that becomes the quorum, right? But in this context, it is the minimum number of servers on which we say, okay, this operation is needs to be performed, right? So that we can say it is successful or not, right? So, if suppose, for example, if take an example where we have three servers and these three servers are serving the various clients, and suppose there is a request to the server one where it is updating some value, right? So, if that value is being set at one server, but other servers are not aware about it, right? So, we have to make sure that other servers are also updated timely. But suppose you are in the process of updating the other servers for this value, but there is a request coming from the client, and your server, right, which is yet having the old data, serves that. It means that you are sending old response. Okay, so that is we have to stop that, right? So for that, we form a quorum uh, that basically defines that whether this transaction is successful or not. Can we respond back to client for request, right? So that is basically the quorum, right? So and how do we decide that if we have three servers in this context, that whether it is a quorum or not? So for that, there's a formula which is n by 2 plus 1, where n is the number of nodes, right, or replicas. So here we can see that we have three replicas, right? So it basically 3 upon 2 plus 1. It means that 2. So if two servers agrees, okay, that this transaction which we are serving is successful, then it is success. Otherwise, it is not, right? So even if one server goes down, you can still serve the customer because you have quorum completed. Now if you take another example where we have five servers or in the cluster, in that case that will be 5 upon 2 plus 1. It means that at least three servers should be available for the quorum, right, to proceed with the transaction processing and sending response back. So now, as we know that normally we have the reads and writes both happening at the same time in system, right? So we normally do that. There might be some master node, or maybe we decide, okay, some particular node is going to take writes, other will be serving as read node, right? So for that, the formula to decide whether how many read write servers we need is basically these R plus W greater than N, where R and W are basically the minimum and minimum read and write nodes, right? And N is number of nodes in that quorum. Okay, so basically whenever you are deciding that in your cluster, how many should be the write replicas, how many should be read replicas, you have to see that you are following this formula for the better or the efficient result, right? So let's understand the this concept by various examples. Let us see that, for example, is that where we have a quorum of three nodes, and in this we have two write nodes and two read nodes. Okay, it means that for any write operation, you are writing it to at least two. I mean, two servers, right? Because you have write equal to two, and then we are reading the also from the two servers. It means that whenever you are writing, you're writing to two servers, and then you are reading also at these two servers, right? It means that whenever you are responding back to your client, your data is consistent, because there would be at least one server in the read, right? Because there are two read servers that will be having the latest data. That's why in this type of scenario, you get a strong consistency. Okay. So now let's see another example. Here we have a node of, I mean, three nodes as a quorum, but here difference is that we have one write server and three read servers. It means that you are writing at one server, okay. Because of that, your write is fast, okay, but you are reading it from three servers. So when you are writing it, it is very fast because writing is happening at only one server. But when you are reading it, it is happening from three servers, right? So you have to make sure that you read from those three servers, and also you make sure that you verify, compare data from those servers and send the latest response back to the client, right? So that's why in this scenario we have fast write, and our read is very slow and not very durable, because read is slow and write is fast here. So it depends upon your use case and scenarios and requirements, but this is not a very good configuration normally in normal cases, right? So let's see another configuration. So in this, right, we have three nodes of quorum, and we have three writes and one read. It means that for any transaction you want to write to all the three nodes as a quorum, then only you will say, okay, my transaction is successful. But when you are reading it, you are just reading from one server, because you have already make sure that you data goes to all the servers, right? So that's why it is consistent, and that's why you are just using one server to read, because of that, right? You are getting the slow write because writing at three servers, and fast read because there is no comparison required. There are the whatever the 214 response request traversal is also not that much, because only one read is happening. So it is in the fast read, right? So these are the few examples to understand how quorum works, right? But suppose you take a scenario where we are writing to all the nodes, right? Suppose you have 20 nodes available in your cluster, and you write in all the nodes but read only from one, right? So it means that even if one server goes down, you cannot fulfill the quorum for the write, right? So it won't be very good configuration in this scenario, right? But normally what happens that systems are mostly read heavy, okay? But yeah, you have to see that whatever requirement you have. So if your system is read heavy, so you can follow this thing, right? So where you are writing in more servers and reading from less servers, so that data is more consistent, right? So you can see that number of nodes are higher than number of nodes where we are writing, and that is also higher than where we are reading. At least one survey is as a right reading is happening, right? So this is like a best configuration. So yeah, so that's it for this video. So I tried to basically cover the concept of quorum so that we understand that when systems are distributed, how we are able to certify that transactions are successful and data replicated across all the servers is also consistent, right? So thank you very much for watching the video. See you next time. Please leave comments or questions if any. Please subscribe as well. Thanks a lot.